Bismillahirrahmanirrahim. Assalamu alaikum, students. Today we are going to discuss another problem. So let me state the problem, then we will discuss the solution. The problem goes like this: a body is dropped from rest and falls freely. So we are asked to find what determine the position and velocity of the body after 1, 2, 3, and 4 seconds have lapsed. So this is our problem. The body is dropped from rest and falls freely. Determine the position and velocity of the body after 1, 2, 3, and 4 seconds have elapsed. Right? So let us move to the solution. We have already discussed the equations of motion for motion with constant acceleration, one-dimensional case. These were the equations. V is equal to V naught plus AT. Then we have X is equal to X naught plus V naught T plus half AT square. Then we have V square is equal to V naught square plus 2A X minus X naught. Then we have X equal to X naught plus half V naught plus Vt. And we have another one, X equal to X naught plus Vt minus half At square. Let me check them. V is equal to V naught plus At. X is equal to X naught plus V naught T plus half At square. V square is equal to V naught square plus 2ax minus X naught. X equal to X naught plus half times V naught plus Vt. Then we have X is equal to X naught plus Vt minus half At square. You know, these equations we have already used. Main ones are the first two. We obtain third, fourth, and fifth from the first two. You know that. When we eliminate time between 1 and 2, we get 3. When we eliminate acceleration, we get this one, fourth one. And when we eliminate between first and second initial velocity, we get this fifth one. Then depending upon the information given in the problem, we can make use of these equations. Now this problem, today's problem, is related to free fall motion. You know, motion near the surface of Earth, when a body falls near the surface of Earth, it is the example of motion with nearly constant acceleration. And you also know that if we allow a body to fall in a vacuum so that air resistance does not affect its motion, we find a remarkable fact that all bodies, regardless of their size, shape, or composition, fall with the same acceleration at the same point near the Earth's surface. This acceleration we call acceleration due to gravity or free fall acceleration, and we denote that acceleration by g. You know this, uh, and you also know this near the surface of Earth, the magnitude of g is approximately 9.8 meter per second square, right? And you also know the fact that the direction of the free fall acceleration at any point is down at that point. Although we speak of falling bodies, bodies in upward motion experience the same free fall acceleration with magnitude and direction. That means magnitude 9.8 meter per second square and direction down. That is, no matter whether the velocity of the particle is up or down, the direction of its acceleration under the influence of Earth's gravity is always down. Right? Now, what do we do when we know the acceleration is constant, and that is g directed downward? We change these equations and make another set of equations for free fall motion. And what we do, we make two small changes. We label the direction of free fall as y-axis. Direction of free fall as y-axis. This is one thing. And take its positive direction to be upward. And take its positive direction to be upward. So our direction of free fall is y-axis and its positive direction is upward. Then we replace the constant acceleration a in these equations. This a is replaced by minus g. Since our choice of the positive y direction is, we have taken it upward, we have chosen upward direction as positive. That means the acceleration is negative because our acceleration is downward, right? So with these changes, these equations for free fall motion become, one is v is equal to v naught minus gt. Then I have y is equal to y naught plus v naught t minus half gt square. Then I have v square is equal to v naught square minus 2g y minus y naught. And I have y is equal to y naught plus half v naught plus v times t. And I have another one, y is equal to y naught plus vt plus half gt square. Let me check them. V is equal to v naught minus gt, y is equal to y naught plus v naught t minus half gt square. Then I have v square is equal to v naught square minus 2g y minus y naught. Then I have y is equal to y naught plus half v naught plus v times t, and y is equal to y naught plus vt plus half gt squared. These are these equations, but with these two changes. We are taking the direction of free fall as y-axis, so x variable is replaced by y variable, and a is replaced by minus g. So let us see now the problem in hand. It says a body is dropped from rest. That means initial velocity of the body is 0. Then it falls freely. We have to find position and velocity at these 4 instants when these times have lapsed 1 second, 2 second, 3 second, 4 second after the fall. So let us do the solution. So we choose our starting point as the origin. So we choose the starting point as the origin. We know initial speed is 0 and v naught is 0 because question says body is dropped from rest. And when we choose the origin at the starting point, that means initial y coordinate is 0. So our y naught is 0, v naught is 0. Which equation we can find use to find the position at 1 second, 2 second, 3 second, 4 second? We will simply make use of equation second. Let me name this second, this first, this third, this 4, and this one 5. So using second, we have y is equal to y naught is 0, v naught is 0, this term will go, y is equal to half gt square minus half gt square. So putting when t is 1 second, when we solve it, y will be minus then the value of g 9.8 meter per second square times 1 second square. When we solve it, it is minus 4.9 meters. You can check the calculation as always at home. Y is minus half 9.8 meter per second square times time square, which is 1 second, so it is minus 4.9 meter. This is the position at t is equal to 1 second. How to find the velocity at t is equal to 1 second? We can use of this equation using first v is equal to v naught is 0 minus gt. Put the values, that is minus 9.8 meter per second square times 1 second. When you solve it, it is simply minus 9.8 meter per second. V is minus gt minus 9.8 meter per second square times 1 second, which is minus 9.8 meter per second. So we have solved the first part of the problem. This is the position at t is equal to 1 second, and this is the velocity at t is equal to 1 second. Now that means after falling for 1 second, the body is 4.9 meter below. Why below? Because y is negative. So it is 4.9. This minus indicates it is below its starting point. So it is below 4.9 meter, its starting point, because y is negative. Its starting point and is moving downward. How do I know that? Because b is negative. That means at that instant, body is moving downward. This negative indicates that from our choice of coordinate system. With a speed of 9.8 meter per second. So after falling 1 second, the body is 4.9 meter below its starting point and is moving downward with a speed of 9.8 meter per second. We can continue in this way and find positions at t is equal to 2, 3, and 4 seconds, and also velocities. In second situation, what you have to do, you have to put t is equal to 2 second in here. You will get position at t is equal to 2 second, then put t is equal to 2 second in this equation. You will get velocity at 2 is equal to 2 seconds. Similarly for 3 second, 4 second, and 5 second. Sorry, 4 second. The question asks us for 1 second, 2 second, 3 second, 4 second. 1 second I have done. 2, 3, 4. You will do it yourself. Solve the numbers. I will give the values. The answers which you will get will be like this. I will show a little figure. That figure will indicate. So if this is t, this is in seconds time, then this is y, position in meters, then I have velocity in meter per second, then I have acceleration in meter per second square. The situation is like this. At t is equal to 0 second, what's y? Y is 0 because we have taken starting point at origin. What is v? V is 0. But what about acceleration? Acceleration is minus 9.8 meter per second square. Now at t is equal to 1 second, we have solved y is minus 4.9 meter. Meter is written. I don't need to write it. Minus 4.9 is 4.9. V is minus 9.8. Acceleration is same, minus 9. Right? When you solve at t is equal to 2 seconds, you will find the position is minus 19.6 meters. Velocity is minus 19.6 meter per second, but acceleration is same, minus 9.8. When you solve for t is equal to 3 seconds, it is minus 44.1 position, and the velocity is minus 29.4. Acceleration is same, minus 9.8. At t is equal to 4 seconds, the position will be minus 78.4 meters. Velocity is minus 39.2. Acceleration is minus 9.8 meter per second square. Let me check it. At t is equal to 1 second, it is minus 4.9 minus 9.8 is equal to second minus 19.6 minus 19.6 minus 9.8 at is equal to 3 second minus 44.1 minus 29.4 minus 9.8 at is equal to 4 second minus 78.4 minus 39.2 and minus 9.8. This first line we have done, we've solved it. This thing you have to solve, you have to check velocity and position at t is equal to 2 second, you have to check velocity and position at t is equal to 3 second and t is equal to 4 second. Using this equation, y is equal to minus half gt square and v is equal to minus gt. You can see, if we go down as time proceeds, speed is increasing. So here velocity vector is directed downward, the body is going down. If I show velocity vector here, it is downward. Here velocity vector is here, also downward, but its magnitude will increase. The speed is increasing here, it is further increasing, it's then further increasing. This is velocity vector. Velocity vector at t is equal to 1 second. It has certain length, but at all position it is directed downward, but this length is increasing. Directed downward because body is going down. But acceleration vector at all positions has same length and direction. It will be directed downward, but throughout the acceleration vector has same magnitude and direction. That is indicated by length of the vector. The acceleration is constant. So let me write. This is velocity vector. This is acceleration vector. So this is all for today. Don't waste your time. Enjoy these problems and do not forget to like, share and subscribe my channel. You can give comment in the comment box. Thank you. God bless you. Assalamu alaikum.